Hello, this topic is on decision analysis and specifically decision trees. Something you may have heard about before, but if not, here's a quick review. We all face these situations, not just in business, in real life even. We have a problem that requires a solution. We have different decisions that we need to make. There is uncertainty in the outcome, events that happen. And so which course of action is the best given this uncertainty? So we understand the problem. We draw a tree. It literally looks like a tree sideways from the trunk to the branches. And it involves decisions and it involves outcomes. So decisions are represented with a square, and we have control over those decisions. So we make the decision, and those decisions will have payoffs, and payoffs are could be profit, could be cost. And then we have possible outcomes that are events that we have no control over. And so these events are represented with a circle, and they would have probabilities. And so the probabilities have to add up to 1. And so whatever the probabilities are, we would have to assess some options first, some outcomes, and then we have to attach the probabilities to them. So the payoffs, the cost, is what we attach to a decision, a square. And so we have this problem that we're looking at, an example in your book, and it's called the ACME, single stage problem. So we're trying to see if we should continue the development and marketing of a new product. Sometimes it would take multiple years to do this, and so we have maybe 1 more year of fixed cost of 6,000, and the unit margin, which is profit minus cost, we anticipate that this would be $18. That's not where the uncertainty is coming from. The uncertainty is coming from if we finish this development and, we predict the market the best we can, the outcome could be great, could be fair, could be awful. And so consumers, once they see the product on the shelf, they may think it's great, and we estimate these three probabilities to be 45%, 35%, and 20%. And so, with 45%, we estimate that the sales volume would be 600. Fair is 35%, and we will sell 300. And awful is 20%, and we sell 90. So then the net revenue is clear. It's whatever we sell multiplied by the unit margin, so B5 times C8, and we copy it here. So the decision we need to make is whether we continue with the development given these odds, or do we take our losses and move it off the table and stop the development, given the prediction. And so the decision tree uses an algorithm called the expected monetary value, EMV, expected because there is uncertainty and we're dealing with probability. And so we draw a tree, and we use what is called the fold-back procedure to go from the tips of the branches all the way back to the trunk of the tree. And that would give us highest expected monetary value. So it'll give us the branch to follow, the course of action. So you see the prescriptive model here is what is the best course of action to follow given these inputs. And so we don't know until we model it as a decision tree. And to model it as a decision tree, we're going to use Palisade's other add-ins, which is called a precision tree. And so here is the solution of this. And this is using the software. I didn't draw this by hand. Mind you, for simple decision trees, you can draw them by hand and apply the algorithm manually. But that's not what we're wanting to do, because these type of problems can get very complex and involve multiple stages. This is what we call a single stage model. So we're trying to decide if we're going to go ahead with the development, continue the development and marketing, or stop right now. So you see that you have to take this problem, any problem that requires decision trees, in a sequential manner as events happen in a chronological order. So this is a tree on its side. The trunk is here, and the tree grows from left to right. And so what do I experience first, time-wise? So expect like a timeline at the bottom here. It says this is a decision I have to make today. Do I continue or do I not continue? So you represent the problems by a series of squares, which are decisions, and circles, which are outcomes, for as many levels as it takes. And then at the end, you fold it back to come back with the best course of action. So this is single stage, which is the most basic and the easiest. We have one decision, continue development or stop. And then if we stop, we don't have any payoff. I mean, we don't get money, and we don't spend money. But if we continue with the development, we have to put minus 6,000, because that's a cost, and so a cost that we have to incur. And so when you're doing this tree, you're selecting whether it's a decision or it's an outcome, an event. And if it's a decision, you're updating the payoffs. You're not touching what is in green or what is in blue. You're only doing these squares and these circles, and updating the payoffs if it's a decision, and updating the probability and the payoffs if it's an event. And so don't touch anything green, don't touch anything blue. It's working as you go along and you enter the information. So let's, and then after that, sequentially in time, there is the probability that this should be, I thought I changed it. This should be great, fair, or awful. And so the probability is above the arc, and the payoffs is below the arc. And notice that all these are referencing the cells. And that's because if you want to do sensitivity analysis later on, if you just have fixed numbers in here, then it's not going to update for sensitivity analysis. So I entered the circle, I entered the reference to the probabilities, reference to the payoffs, and then the solution, the best course of action is if it is, you follow the route that says true, true, true to the end. So the expected monetary value is going to be 1074. So if this is in thousands, the numbers, then it's about $1 million. And it's telling me that you're better off continuing the development and marketing the product. Given these probabilities, given these numbers, and given this uncertainty and the cost of the project. So how do we do decision trees? We go again to Palisade software. So we have, let's see, Palisade. We have precision tree, and that's what it's called. And so it will put a ribbon here when it opens it. And if you don't have Palisade installed, when you open the solution, it's going to show you hashtag, hashtag, hashtag. And so that's because I have it installed here on my computer, so that's not the problem. But this is the precision tree. And so I'm not going to show you all the steps because you can follow what's in your book. But if we go back to the shell, and we come here and we go precision tree, you start it anywhere where it's free and you go, I want to build a spreadsheet. And so I want to build a decision tree. Choose the location. I say I already chose it. And you will get dialog box after dialog box until you're done with the problem. So we said square, circles, and then Palisade uses a triangle until you finish the branch, at the end of the branch. So I can name it here. I can say company decision. And I just say, OK. And so it puts the label here. Then I go chronologically defining the problem. So I click on the triangle and I say the next thing is a decision. And so the decision is going to be a square. I can name it continue. Do I continue development? Question mark. And then here are the branches. You can name you start with 2 branches, which in our case is OK. We want to continue development or stop. So if you need more branches, if the decision involves 3 decisions, then you add a branch like this. But we don't have 3, so I'm going to delete it and say OK. And this time, I don't want to name them inside here. I want to name them on the branch. So you get branch 1, branch 2. You can click on the branch, and you can say continue. Development and marketing. And so that would be continue. This will be, we can click on it and say stop development. And so, and marketing, however you want to name that. And now immediately I will have to update. Remember, you don't touch the green and the blue. So I would go equal minus the 6,000 here, right? If I continue, immediately you update the costs and the profits and the payoffs as you go along. So there is nothing to update if we stop the development. So we'll leave it at that. And then here is where the uncertainty will come. And so now I have an event, and so I need to use a circle. And so I say chance, and the chance is going to be the market. What would the market turn out to be? And so since I have great, fair, and awful, I have 3 options, so I need to add a branch here. And so say OK, and it gives you a circle with 3 branches. You'll rename these branches as branch 1, 2, as great, fair, and awful. This is just entering a decent label. And then you update the probabilities. So again, you go equal and this probability. Equal. So with decision, you have only the payoff to update. With this, you have probabilities with a circle, an event that you don't have control over. You have a circle. You have to do the probabilities above the branch and the payoffs under the branch. So this would be equal to this. number, this will be equal to this, and this will be equal to this cell reference. And that's it. There is no button that says start or run or anything like that. The precision tree is one where it's updating as you enter the information. So going back to our solution here, which already entered all these formulas, so we see that everything, this was a mistake on my part. So this is how you would say this should be great. And so already we know that we should continue development and marketing of the product because that's where the true is. And there is a positive expected monetary value of this option, whereas this, you get nothing, zero. And so you can read the solution here. You can do sensitivity analysis here. But how do we get the optimal tree and the probability chart? And so those are ones that you need to get after you model the solution. So I'm going to delete these here and show you how to get those. After you finish modeling the tree and putting the payoffs, probabilities, everything looks good, nice labels. And so now this is how you get. So if my tree is too huge, too big, and I can't see true, I can't keep tracking true on the tree, I would want to do this. And so I would go, what is the policy suggestion for this model? And so I just want the optimal decision tree. I don't want anything else. And so if I click OK, notice how it put the optimal decision tree in my spreadsheet. And so if this is like a huge tree, it goes, extracts the true path that it is recommending you follow. And so in this problem, it recommends I continue development. I already knew that from the tree itself. Another thing that is very important is to get what we call a risk profile. And the interesting one is the probability chart. Because this is a problem under risk, a problem under uncertainty, I would like to see my risks. And so I say, OK, it puts a probability chart inside my spreadsheet. There is an option to put it in a separate spreadsheet, but why would you want that? For this class, we want it to be in the same spreadsheet. So it is the less number of files, the better. And so here is the risk profile. And so what it's showing is the red line shows the positive on the right side and then shows the negative on the left side. And so it's showing the positive is we can, with 40 almost % chance, we can make this profit, 5,000, or with negative payoff would be these probabilities. So why do we have three options? The three blue lines are actually your three options on the tree. So you have the end result is you have three options, right? So you will see those options, 45% on the tree, 35% and 20%. And those are what you would be making in payoffs. And so that's your risk profile. You may make money with a certain %, and you may lose money with a certain %. So these two options, you're losing money. These are the two blue under the zero in your risk profile. This is the two scenarios. If the market turns out to be fair or awful, I'm going to be losing money with these probabilities. If the market turns out to be great, then I'll make money. But all in all, this is called a risk profile. It shows you when do you make money and when do you lose money and with what probabilities and with what expected payoff. It's like when you go to a financial advisor and they say, if you invest in this aggressive portfolio or moderate portfolio. You can make, based on historical return, you can make up to this, but you can also lose money. I mean, the markets are unpredictable. So they show you a chart with a positive and a negative. Maybe they display the negative under the x-axis, but it would show you with what probability, it would show you a risk profile. This is what your risk is. That's why financial advisors give you a questionnaire to assess what kind of risk you are willing to tolerate based on your age and many other factors. They decide whether you should go with an aggressive portfolio or moderate portfolio or moderately aggressive. They have many different ones. And based on the history of the markets, they can assess positive years that the market is doing well and negative. So you put $1,000 in the market, you may end up a year from now with a positive income, but you could also lose money. So they show you these risks, and that's called a risk profile, which is what these three options are. So, so that's called a single stage model, because we're having only one time we make a decision, one time we get an outcome that we don't have control over, and we assess probabilities and payoffs. And this is the one that is, it's using, Palisade is using the foldback procedure, which means we can do this manually. It's easy to do it manually, but if the tree goes through multiple decisions, multiple circles and events, then it becomes difficult to keep folding back one level at a time and apply the algorithm manually. So that's the next example. It builds on this example, which is, yeah, I have another stage here, which is I split, first of all, the development and the marketing cost into 4,000, 2,000. And there is a technological issue that is involved in the development that has a 20% probability of failure. So introducing another level of uncertainty where it would be, it would fail possibly 20% of the time. So how are my odds now while the great, fair, awful stays the same? So following the same steps and instructions as your book, we look at the solution here. And so now my tree is multiple stages. It's still a relatively small tree, but you're getting the idea of how this works or not. So again, the x-axis is your timeline. So we start today. Do we continue development? And so yeah, if it is yes, then the development is 4,000. And so now we split it into development and marketing. It used to be in the first example all lumped together. Do we continue development and marketing? And that's 6,000. Now we're saying, okay, first decision to make is, do we continue in the development? And so we put a payoff of 4,000 or not. So we put continue development label, yes, no. If we don't continue, then there is nothing else. So we grow in this branch. And now, in the development, is there a technological success? I mean, because there is 20% chance we may fail. We pay the 4,000, but we fail because of technological issues. And so technological success would be 80% and 20% failure. And there is no payoff for that. We just say yes or no. And then that would be, yes, we succeeded. If there is no success, then all we did was 20% chance we lost $4,000, basically. And we can't get that money back. It's lost cost. And so, but if we succeeded, which is 80% of the time, then now do we go to the next stage and market the product? If yes, we market the product, we incur the 2,000, so that's a negative referring to the spreadsheet cell. And if we decide for whatever reason, even though there is a technological success, we don't proceed, we just stop. And so we still lose the $4,000 since there was no payoff for technology. And so for the technology test. And so then we continue with the top branch, and then if it is a yes, there is technological success, we want to continue marketing the product, then we get that small subtree that we did before, great, fair, awful, and you put the payoffs under the branch and the percentages above the branch, and that's it. And so now this is a slightly bigger tree, and if we want to see what Palisade is suggesting, the precision tree algorithm, it's following the true. And so true is saying, yes, continue development and continue marketing, because still the odds are in your favor. You will have a positive expected monetary value. So that's, unless something changes in the inputs, this could change. But otherwise, we're good to go. We generated the optimal tree and the probability chart like we looked at before. And so the optimal tree will give us the optimal path. It'll extract it from the tree. And so, yes, continue with development and marketing. And the probability will give us the risk profile, which is 4 outcomes this time, 4 outcomes of 4 possibilities. And it looks like the 0 is here, 1 is positive, and the other 3 are negative. But in totality, this would be the option to do that. And I forgot to mention that it will give you also you don't have to look very closely on the chart to try to guess the probabilities or the outcome. It gives it to you in a table as well. And this should match the tree like we saw earlier with the single stage. Now, there is a lot to learn about each of these add-ins. I mean, there is a whole documentation of each of these add-ins. But here we just covered the basics, and then it's up to you how much you want to grow your knowledge of this area. If you want to learn more about sensitivity analysis or the settings or any of these other options, you're going to have to read it on your own. And it depends also on what you need. And so we tried in this advanced business analytics to cover several advanced models under uncertainty, and so descriptive, predictive, and prescriptive. And so then if you find you're using genetic algorithms, you go cover more genetic algorithms. You find you're using more precision tree, then you have to get more in depth. And there are videos and documentations online that would help you with that. So this is decision tree, and thank you.